All right, so factoring. This first one, if you remember back in Algebra 1 when you first started factoring, you might have had an example like this. X squared minus 4. Now, that's hopefully and probably a very easy factor problem for you to do. You split up the first perfect square, x and x. You split up the second perfect square, 2 and 2. One's plus and one's minus. Doesn't matter if it's plus and then minus or minus and then plus. It is the same thing with words. We learned yesterday that sine squared x means sine x times sine x. 1 is still a perfect square, so if we were to factor this, we would split up the first perfect square, split up the second perfect square, sine x, one's plus, one's minus, and it's factored. Now, just like yesterday, that's not always what is best to do. It depends on the problem. So let's look at this third simplified problem. We'll get back to this one in a second. 1 minus sine squared x. Yesterday, we learned the Pythagorean identity, where we could change 1 plus sine squared x to cosine squared x. That might be something you need to do. It might not. This third problem right here, if we were to change this numerator cosine squared x, that doesn't do anything for us. There's nothing else that we can do. So, something else that we can do now is factor that. So, if I factor this numerator to 1 plus sine x times 1 minus sine x, just the difference of two squares with words versus letters, and then put the denominator, now we can cancel things. So this 1 minus sine x cancels with that 1 minus sine x, and we're left with 1 plus sine x. Now, yesterday I said you're trying to get rid of fractions, always, and you're trying to get it down to a single term. But this is not a single term. This is two terms. So when is it okay to have two terms? When is it not? Whenever you have two terms, and one of them is not squared, and the other one's a number, then you're done. There's nothing else to do. If you have a 1 with something squared, or two words that are squared, then you have to look at your Pythagorean identities, see if you can rearrange them to get it to equal something. 1 plus sine x, there's nothing else we can do with that. So we have two terms, but there's nothing else we can do. So that is all we have left. You cannot go up here and start canceling those ones. If I had 1 plus 3 over 1 plus 4, is that equal to 3/4? No, not one of you would tell me that's equal to 3/4. It's no different when we have words. We can't just get rid of those ones, negative over negative is positive, and then get our answer. We cannot do that. The only time you can simplify is when you're multiplying. So we have 1 plus sine x times 1 minus sine x over 1 minus sine x. Now we can start canceling. When you're multiplying, you can cancel numerator and denominator. When you're adding and subtracting, you can only cancel something that is exactly the same. If it's not exactly the same, we can't cancel it. So that's another tool that you're going to need to use when you are working on this entire lesson. This other thing I kind of added to it, so this is what's on your notes, but I added a little bit to it to compare the two. Because yesterday we did sine x times sine x. And we learned that that was sine squared x, because we're squaring the entire sine x. We're not just squaring the x. If we have sine x plus sine x, which all of you know, if I said, is multiplying and adding the same, you would all tell me no, and I know you know that, but we start putting words in it, and now all of a sudden all of that, those algebra skills you had went out the window. Okay? This is multiply, this is add, so the result is not the same. So this would be 2 sine x. That's something you might have to do as well, combine like terms. On your homework you had one like that. There was, I think, a tangent theta minus tangent theta. Those are like terms. They went away. Tangent minus tangent is 0. Tangent plus tangent is 2 tangent. The other one where we would square the x would be sine of x times x. That is what's equal to sine x squared. Okay, so this we'll get to later, These are the two that you'll see in this unit. But just notice all three of those are different. Therefore, all three have a different result. Right now, you have to worry about squaring the entire trig function, or adding or subtracting them or changing them using the Pythagorean identities. All right, so again today, factoring and getting an LCD. Those are the two things that we have to think about along with what we did yesterday. So this first example right here, we look at it, secant minus cosine over tangent. There's no identity there, Pythagorean identity, because nothing's squared. So when that's the case, we usually want to leave sine and cosine alone, but if there's any secant, cosecant, tangent, or cotangent, we want to change those. So I'm going to change this to 1 over cosine x minus cosine x over sine x over cosine x. And I'm going to make this a denominator of 1 just so that you can see all of them are fractions. It's not necessary, but for some people that's helpful. So if I have a bunch of fractions and I have a fraction in a fraction, I want to get rid of those denominators. So the way that you get rid of the denominators is you multiply through by that denominator. But we can't just randomly multiply by a word or a number or a letter. But we can randomly multiply by 1. So if I multiply this whole thing, I want to get rid of these cosines. If I multiply the top times cosine x and the bottom by cosine x, I can get rid of those fractions. Not the entire fraction, but the fractions within the fraction. Cosine divided by cosine is 1. So I'm just multiplying by another version of 1. It's just like when you had fractions that were numbers. 1/3 plus 6. We made that 1/3 plus 18 over 3. We got a common denominator so that we could do that. So it's kind of like getting a common denominator. But we're multiplying through to get rid of the denominators. This is not the only way to work this problem. There are lots of ways to work this problem, but only one answer at the end. So I have to distribute that to both terms. 1 over cosine times cosine is 1. Minus cosine times cosine is cosine squared x. Sine over cosine times cosine is sine, because the cosine on top cancels with the cosine on bottom. So now I have two options. 1 minus cosine squared x. That's the difference of two squares, so I could factor it, or I could use my Pythagorean identities. So if I factored it, I would have two different terms with plus or minuses. Will that help me for the bottom on this one? No. But if I turn this into a single term from our notes from yesterday, remember all these ways that we can manipulate the Pythagorean identities? Right here, we can change 1 minus cosine squared a into sine squared a. So that's what I want to do on this one. I want to make the top sine squared x, the bottom is sine x. Now, some of you can come up with the answer from there, and that's fine, but if you like to expand it and actually simplify it, you can do that also. So remember, sine squared x is sine x times sine x over sine x. Now, we can't cancel all the signs in the top. We have two signs in the top and one in the bottom. So 1 in the top will cancel with 1 in the bottom, and you're left with sine x as your answer. Now, you could go from here to here. That last step I showed right there, you don't have to do this. I'm just doing that so you can see how I got this. You can cancel this sign with that too, because then it goes to 1, and come up with your answer that way. So Pythagorean identity, the first one, I just manipulated it, and that was from yesterday. Remember, we showed all the different ways you can manipulate it. So anytime you have sine squared and cosine together, or a sine squared and a 1, or a cosine squared and a 1, some kind of version of that, you want to use your Pythagorean identities. Because most likely, there's some kind of manipulation you can do to get it to be more simple. Other questions on where anything came from there? Just as a preview for Monday, when we add the proof part to this exact problem we could do as a proof. All that would change is this would say equals sine x. and it would say prove. These exact same steps, and then you would just say, what did you do? Well, so from here to here, I got a common denominator, or I multiplied through to get rid of the denominators, or I got a common denominator. Then I added, then I used the Pythagorean identity, then I simplified. Those are reasons why. Not like geometry where you have to like recite some postulate or theorem or something like that. You have to remember the identities. Okay, that's the part that's new. But other reasons: add, subtract, combine, simplify, reduce, distribute, factor. Those would be things that get you to the answer. All right, so this next one, 1 plus cosine y over 1 plus secant y. Again, neither one of those are identities. So there's nothing we can change. All of the Pythagorean identities have something squared. So the next step would be change everything to sines and cosines. Cosine and sine we want to leave alone. But this secant we can change to 1 plus 1 over cosine y. And just like the first one, you want to get rid of that denominator. So to get rid of that denominator, we can multiply through by cosine y over cosine y. And this is not the only way. First period I actually did this a different way, and it took a few more steps. And then last period, I worked it this way. So it just kind of, even I don't work it the same way every time, because when I look at it, I might see something different. If you see something different, that's fine, but when you get to the answer has to be the same. So now I distribute, so I end up with cosine y plus cosine squared y over cosine y plus 1. Because when I distribute that, and I distribute that, I end up with that denominator. Now, I cannot just cancel cosines. Okay, do not get cancel happy and just say, okay, this goes away, that goes away, I'm left with cosine. That is not the answer. Okay, do not do that. You can only do that if these plus signs were times signs. Then we can start canceling. Plus and minus, we cannot just start canceling. So now when I look at that, similar to what we did yesterday, that numerator has a GCF of cosine y. So I take out the cosine y, and I'm left with 1 plus cosine y. Don't forget about that placeholder. If there's a plus sign and you're factoring, you have 2 terms, you have to keep those 2 terms. You can't turn 2 terms into 1 by factoring. You can only turn 2 terms into 1 by substituting using a Pythagorean identity. And then that's going to be over cosine y plus 1. Well, all I did was factor the numerator on the top. The denominator, there was nothing to factor because there was nothing squared. But in the numerator, I had a cosine here and 2 cosines here. So because I had 1 and 2, I could take 1 out. And I can't get rid of it, but I can factor it out. Because if I were to distribute that back in, I would still end up with what I started. Now I can simplify. Is 1 plus cosine the same as cosine plus 1? Yes, if the signs are both plus, it doesn't matter what order. So those cancel. And now they don't cancel to 0. What do they cancel to be? 1. So cosine times 1 is cosine. All right, so when you cancel things, remember, things don't cancel. You can have 0 as an answer. Okay, but that's if you're adding and subtracting. The only time 0 can be a possible answer is if you have adding and subtracting in the problem. If all it is multiplying and everything cancels out, it's either going to be 1 or negative 1. Those are your options. Questions? All right, this one looks kind of ugly, but it's really not that bad, because if we look at it and we use our identity sheet, we should hopefully, I don't know what that is. That is correct. The bottoms are both Pythagorean identities. So if you look at your identity sheet, 1 plus tangent theta is secant squared, and 1 plus cotangent squared theta is cosecant squared. Your second and third Pythagorean identities. So this ends up being 1 over secant squared theta, 1 over cosecant squared theta. What is 1 over secant squared theta? As not a fraction. Is that one of the identities, the top ones? Is that a reciprocal identity? It is. That's cosine squared theta, because remember those reciprocal and ratio, they can be squared, cubed, fourth, fifth. You can do that to those. Plus 1 over cosecant sine squared theta. And what's cosine squared plus sine squared? 1. So that one looked kind of ugly to start, but 2 steps and you have your answer. Your first Pythagorean identity. Okay? So anytime you have things squared, and there's adding and subtracting involved, adding and subtracting with squared, you want to go right to those Pythagorean identities. What I would do on Tuesday when I give you the quiz, write those Pythagorean identities. Have them practice every night. Go home and just practice writing them down. Keep practice. The more you write them down, the easier it's going to be to know them for your tests and quizzes. Okay? Do what? What does it say on your syllabus? Yep. Other questions about the problem? It's better than the day after Halloween, right? Yes, I agree. Yes. Because y'all go trick-or-treating, I guess, right? 2 terms, you always have to get a common denominator. So before I do anything, I want to change this tangent to sines and cosines. So cosine A over 1 minus sine A minus sine A over cosine A. Now, it's still not a very small common denominator, but we need to multiply the left side, but whatever's in the denominator on the right, and the right side, whatever's in the denominator on the left. So, this side we have to multiply by cosine A over cosine A. Now, if you're going to show that you're getting a common denominator, you have to show it correctly. You cannot just multiply by cosine A. That is different than cosine over cosine. Multiplying by cosine versus multiplying by cosine over cosine is completely different. One of them's multiplying by cosine, the other one's multiplying by a version of 1. So I don't have to see this, but if you write it, it has to be right. Don't be halfway. Halfway is wrong. Okay, don't be lazy. Either don't write it at all or write the whole thing. Same thing over here. 1 minus sine A over 1 minus sine A. If you're going to show that, now you have to do it. You don't have to show it. If you're going to show getting a common denominator, you have to show it correctly. You can't just write half of it. You have to write whatever on the top divided by the bottom. So now I'm going to multiply this. So the numerators, I'm always going to distribute. I'm not going to distribute the denominator because a lot of times what happens, especially on the simplifying problems, your goal is to cancel things, and so your numerator usually turns into something that you can cancel in the denominator. So it's not wrong to write the denominator as cosine A minus sine A cosine A. You're just probably going to have to factor it back out at the end. So then here, the numerators, we usually do want to multiply together. And my denominator, I'm going to leave the same as well. So now I have a common denominator. So when I have a common denominator, I can combine my numerator. So my numerator is going to be cosine A squared minus sine A minus a negative, very important that is plus sine squared A. That minus, when there's a minus in between, it has to distribute to both terms. If it's plus, the signs stay the same. I multiply something by plus 1, stays the same. Minus 1, the signs change. And all of that is over cosine A times 1 minus sine A. You cannot cancel. Okay, you have adding and subtracting. There's no canceling to do yet. Oh, this should say, yes, thank you. That should say A. All right, everybody good so far? So now my numerator is what I need to try to condense. So could I rearrange my numerator into a different order and it'd still be the same? Yes. So when I look at that, I have cosine squared A plus sine squared A. Does that equal something? It equals 1. So I could replace cosine squared A plus sine squared A with 1. And then I still have the sine A over cosine A times 1 minus sine A. And now look how nice that is. Cancels, cancels. Again, it doesn't cancel to just go away or it becomes 0. It becomes 1 over cosine A, which is what? Secant A. No fractions. Got to get rid of fractions. And we have our answer.